What is an arithmetic series? An arithmetic series is a sum of an arithmetic sequence. Let's look at an example. Think of the following arithmetic sequence. Of course, this is an arithmetic sequence since the common difference is 3. So the series of this sequence will be the sum of the following numbers. And so this is the sum of 6 terms that will give you 57. So 57 is the arithmetic series of this sequence. So the arithmetic sequence is simply the list of the numbers, whereas the series is the sum of those numbers. Let's look at another sequence. Suppose we go all the way to A100. So again, this is A1, A2, A3, A4, right? We can go all the way to A of 100. Now let's say we want the sum of these 100 terms. So you could do 2 plus 6 plus 10 plus 14 plus 16 all the way to whatever that number is, but obviously that would take you a long time. So there must be a formula to use. So to be able to do this, let's find what A of 100 is. We know that A of 100 using the arithmetic sequence formula would be A1, which is 2, plus D, which is common difference 4, times N, which is 100, minus 1, and that will give us 792. So the last number here will be 792. So how do we add these numbers? So before we do that, let's look at a simple scenario, then we will come back to this one to finish it off. Suppose we just have some easy numbers to work with. Think about this. This is A1 and this is A6, and the common difference we know it's 1. Now we want to find the sum. Now I am going to rearrange these numbers from the greatest to the least. So I have 6 plus 5 plus 4. What I did so far, I rewrote the same sequence again in the reverse order. Now I'm going to add them. So 1 plus 6, that's 7. 7 plus, this also will give me 7, plus this also will give me 7. See, I get 7 everywhere. So, and then how many 7s do I have? I have 6 7s because I have 6 terms. Remember, this is A1, A2, A3, A4, A5, and A6. I have 6 terms. That means N is equal to 6. So I will multiply 7 times 6. However, I will have to divide this by 2. Why? Because I wrote this sequence twice. I wrote it here, and then I added it. So if I want to find the original sequence, I have to divide that by 2, and that would be 21. Now let's add these numbers, see if we get 21. So here I have, that's 3, that's 7, that is 11, that is 10 plus 11, that's 21. So what would you say is the general formula for this? Let's see how we got 21. We took this number A1 plus this number A6, and then we multiply by 6. What does 6 mean? 6 is N. We multiply by 6, then we divide it by 2. Now let's see, however, what does that mean? What is 6? 6 represents the number of terms. So in other words, you may say that the sum, when you have n terms, is going to be n times A1 plus AN. Again, that's A6 is AN. That's the last term divided by 2. N means number of terms. AN means first term. AN means last term. And S of n means the sum of n terms. However, this works only when you have an arithmetic sequence. Now let's come back to our original question. Let's rewrite the formula first here. Now let's substitute. We are looking for S of 100, which means 100, which is n, times A1, that's the first term, is 2, plus AN, the last time is 792, divided by 2, and the final answer is 39,700. Let's look at another example. Find S of 12 for the following sequence. Let me write down the formula again. How many terms do I have? I have 12 terms, so I know that S of 12 is going to be equal to 12 times a1, which is negative 6, plus a of n, I don't have that one yet, divided by 2. So I need to find this number right here. A of 12, I use the explicit formula for the arithmetic sequence, is a of 1, that's negative 6, plus d, the common difference here is negative 3, correct? So times negative 3, 12 minus 1, so that's negative 39 here. Put it right here, that's what I'm looking for, and then I work this out, negative 270. In other words, so what that means basically is I'm adding these negative numbers until the last number, which is supposed to be negative 39. I will get to negative 270, and that would be the sum of the 12 terms.